Okay, sorry about that. Back into using our tangent that we just found at 3.5, plugging that into area of this triangle. So our base is 4, 1/2 times 4 times the height, which is that apothem that we just found, 3.5. And so then our area is about 7, because half of 4 is 2. 2 times 3.5 is about 7. And again, that's one triangle. So if I multiply that by all 6 triangles in the hexagon, my area is about 42. And that is a lot closer to what we got down here using our special rights. So make sure you choose the correct ratio. Don't make that mistake. But it should work either way. Now, on quizzes and tests and different items that you're going to be asked to solve, if it asks you for an exact answer, then this is the exact answer that has the radicals still in it because there's no decimals that have been rounded off. If it asks for an approximate answer, then you can give the one with the decimal. All right, so let's move on to page 458. All right, so this page explains where we get the formula for area of a regular polygon. So, oops, I'm on the wrong page. 458, here we go. All right. It asks here, it says, now we can use what we discovered to generalize the formula. Refer to these two diagrams of regular polygons. This is a pentagon, and it has 5 sides. So n in this case is 5. And then this one, 2, 3, 4, 5, 6, 7 is an octagon. And so n is 8 because it has 8 sides. All right, how many triangles are formed when the radii are drawn from the center of the polygon to each of the vertices of a polygon with n sides? Well, how many triangles are formed in a pentagon? If I draw all the radii, again, it's a radius because it's going from the center to the circle, and it creates 5. Over here with the octagon, how many do you think it's going to create? Of course, it's going to create 8 triangles because it's going to 8 vertices. And so then the way we generalize that is we say that the number of triangles formed is based on the number of sides. So if there's n sides, there would be n triangles. The number of triangles matches the number of sides. What is the measure of each of the central angles formed by the radii of the n-gon? Explain how you arrived at your answer. Well, remember these interior or central angles, we took 360 and divided it by however many angles we have there. That was in our last lesson, 31-2. So that's how we would do it here. 360 divided by n is where we would get the one central angle, and that comes from that inscribed circle. N means within, scribed is written within. So here's our inscribed circle that we create with all of those central angles together. Next, classify the triangles formed by the radii by their side length. Verify your answer. Well, every time we do this, these radii are all the same measure. And so what we create, if you look here, we've got a triangle with 2 congruent sides. So every time we're creating an isosceles triangle because all the radii are congruent. Okay, so next, write an expression that finds the area of one triangle in an n-gon. Use A to represent the apothem. Use S to represent the side. And then use the expression to write a formula that finds the area of the entire n-gon, where n is the number of sides of the n-gon. All right, so here we go. Just to find the area of one of those triangles, we would need to know the apothem, right? 1/2 of base times height. Well, we're going to rewrite that. 1/2 of base would be the side length times height is the apothem, right? That's one triangle. And then we would multiply that by the number of sides because that's how many triangles there are. I think I have too many parentheses in there. I don't really need this one. 1/2 of side times apothem times the number of sides. So the single triangle area was 1/2 of base, which is the side, times apothem. And just know in, algebra, we always should be listing our variables in alphabetical order, so you will see it rewritten that way. The full polygon area would be 1/2 of apothem times side times n. Okay. Now, how would we find the perimeter of this polygon? Well, we would take however many sides there are and multiply it by the length of one side because they're regular polygons. And so in this case, we would take the number of sides times the side length. So P is equal to NS. All right, well, guess what? Right here, I can replace this right here. That's the same thing. And so what's going to happen is we're going to substitute P into that formula, and now we've arrived at the formula for area of a regular pentagon. Area is equal to 1/2 of the apothem times the perimeter. Okay, that P just replaced the SN. The S was really the B in the triangle formula, the base length. N is the number of sides. That's how many times we had to multiply the area, and that's where we get that formula.